Okay, so we're going to start Unit 7 today. Now I have to talk about Unit 7. It is a fairly easy unit. It doesn't always appear that way, but it actually is. It has, everything is about using tables and plugging in formulas. So you're not going to have a whole lot of interpretation of questions. You will have to do some, but most of it is about literally plugging into formulas. So you'll get a note card like you did last time, and all you have to do is plug in formulas and find numbers on charts. So the first section, and all the sections are like this, they're on something called confidence intervals. And what a confidence interval it is something to say, I took a sample and I found a mean, and how confident am I that my mean is real? And I know that seems like a strange concept, but in statistics, we're always looking at the possibilities that my data is wrong, that I have done something that that is not quite right. So we start with confidence intervals, and we're going to build on this idea in chapters 8 and 9. But so we start with this idea that how confident am I that my mean is real, or that my mean, or what means would be realistic for my data. So all this is about finding confidence intervals, and we're going to find confidence intervals for different types of data. So the very first thing that we have to do is we have to determine what we're going to use as an idea for our population mean. So we're not actually given the population mean. We're finding a sample and finding that mean. Now sometimes this will be given to you. It'll say sample was found. Sometimes you'll have data and you have to find it on your own. You need a graphing calculator for that. Okay, so a point estimate, and when it asks you for this question, and it's going to ask you in your assignment today for point estimate, is a number that we're going to say, we're going to use this to predict the population mean. It always is your sample mean. So when it asks for the point estimate, it's your sample mean. And then we're going to find an interval estimate of a range that this true mean could be in. And that we're going to use formulas for that. So you'll be given formulas, you're plugging in numbers. It looks complex, but it's not really. So we're going to continue here with this. You can read through this. The information is all in your books. It's good about what a confidence interval is. We're going to start with a formula. And this formula, again, looks confident. It's called confidence interval. All right? So it's the idea that I am 90% sure, 95% sure, 99.5% sure, or maybe I'm only 70% sure that my mean is within this range. So we do this by taking the sample mean that we found and we subtract a z-score. Now it says alpha over 2, which means that I need to divide my confidence interval in half so that I have half on the top and half on the bottom. And then you take the standard deviation divided by the square root of n. And then we take the mean plus that same number with standard deviation divided by n. Now, most of the time, you will use a 90% confidence interval, a 95% confidence interval, or a 99% confidence interval. These are very, very easy to find. These numbers, you have to memorize them or write them down on a note card if you're going to use it. So for a 99% confidence, my z-score is 1.65. For a 95% confidence interval, my z-score is 1.96. And for a 99% confidence interval, my z-score is 2.58. So anytime you see these three numbers, you will use these z-scores. So write them down somewhere so you don't lose them, so you don't need the charts or anything. So here's an example. It says, a study of 35 golfers showed that the average score on a particular course was 92. The standard deviation is 5. Okay, find the best point estimate, find the 95% confidence interval, and then says find the 95% confidence interval if the sample was 60 instead of 35, and which one is smaller, and explain why. So let's look at this. First of all, the point estimate, remember, is our sample mean. So whatever our sample mean was, in this case, was 92. So our point estimate is going to be 92. This is what we're predicting the mean should be. Now, 95% confidence interval is I take 92 minus 1.96, remember that number is for 95%, times the standard deviation over the square root of 35, is less than 92 plus 1.96 times the standard deviation over the square root of n. Again, all I'm doing is plugging in formulas. This is not difficult, all right? Then I finish this out, and I say 92, or I find my values. Doing math in a calculator. Use your calculator, use parentheses, be careful. Calculators can be deceiving sometimes. Make sure that your numbers make sense. You'll know if you did something wrong if, first of all, your mean is not in between these two numbers, okay? If I get a number like, if I said 100 and 150, I've done something wrong. Look for realistic. My mean is going to be somewhere between 90.3 and 93.7, and I'm 95% sure that the true mean is between these two numbers. And so that's what we're looking for, is what's the true population mean if my sample is 92. I'm not sure that I actually did C and D. I didn't, I apologize. Sorry. Whoops, we're going to go back. Went too fast. So this is your, I'm sorry, messing up in the video. Okay, this is your practice problem. Okay, so on your practice problem, you're going to use a sample mean of 50, or sorry, not a sample of 50, a mean of $19, and a standard deviation of 68. Plug into that formula, all right, with a 95%. Remember, 95%, my z-score is 1.96. All right, once you're done, check the answer. All right, here's the answer. Okay, I simply plugged into a formula. I can't tell you how much this is all this chapter is, okay? Now, sometimes it's interpreting what formula to use, but for the most part, you're plugging into a formula. All right, so that's my practice problem number 1. Now, example 2 uses another formula, okay? Now, this one says, what happens if I want to have a 95% confidence interval with around the mean if I want to be accurate within 15 cents, okay? So this is important. So it's saying, what's my margin of error, okay? How much do I want my mean to vary? So this one I use a z-score with the same, whatever confidence interval I am. In this case, it's 95%. My z-score is 1.96. And then my standard deviation. And then I divide it by my error. What do I want my error to be on my mean? And that's usually this number here. So when it asks the question, how large should a sample be? This is the formula you're going to use. So I'm looking for how many people do I have to ask, or how many pizza shop owners do I have to ask to get a good confidence interval for this. So plug in the formula. Here we go. So my n is going to equal the z-score, all right, which is 95%, so it's going to be 1.96, times the standard deviation over my margin of error, okay? This is my maximum error that I want, squared. So I have 1.96 times 0.26 divided by 0.15, that's my error. I messed up when I wrote this, I apologize. That should be 0.15. I'm not sure what I was thinking. The number should still be accurate, my answer. So 3.397 squared. So 11.5. So I think I messed this up when I was doing it. So check the numbers on this. I try to copy the examples so that I don't mess them up, and I think I messed up when I was writing numbers down. Margin of error should be 0.15, and that would probably change these numbers a little bit. But what it will do is it will give you the population size. So let's look at the practice question. Okay, college president asked the statistics teacher to estimate the average age of their students at their college. How large of a sample is necessary? This is the key word. Lots of people ask me what's the key words in the questions to know what formula I use. how large a sample, this is the keyword. The statistics teacher would like to be 99% confidence, and the estimate should be accurate within 1 year. From the previous study, the standard deviation is 3. Okay, so go ahead and do that problem. Okay, here's your answers. Okay, so if we want, so my z-score based on the chart that I have for alpha over 2 is 2.58. I'm going to talk in class about how to find this if it's not one of the ones that are the easy ones. My margin of error is 1. All right, so I plug my numbers in. My 2.58 times my standard deviation divided by 1 squared is 59.9. So I need to have a population size of 60. So, and I do think that is it.